close your eyes and try to imagine nothing. You cannot. And that impossibility is where our story begins. To imagine nothing, there must be a you to do the imagining, and a mind cannot picture its own absence. When you let your eyelids fall, even the darkness that blooms behind them is full of memory and sensation. The fear that haunts us is not simply fear of death, but of disappearing into a void without witness or return. It is the dread that there might be an end with no echo, no circle back to the beginning. Ancient myths and modern science alike whisper that this dread is unfounded. Time, they suggest, is not an arrow shot once into oblivion, but a path that curves back on itself. Stars explode and scatter dust, and in the cold drift of space, new stars ignite. Each death births a new beginning. In this circle, nothing truly ends. Everything transforms. If you are new to this space between thought and sleep, welcome. Press whatever button you need to press to return here whenever you like. Now settle into your chair or lie down. Unclench your jaw, soften your brow, and release the day's weight from your shoulders. Take a breath as deep as a universe. Feel it fill you, and then sigh it away. You have embarked on a journey into the infinite loop. Our pace will be slow, the tone gentle. We will wander through physics and philosophy, through stories of atoms and theorems, through the soft hum of quantum possibilities. This is not a lecture, but a lullaby stitched together from facts. Let each word wash over you like the sound of waves on a dark shore. Let your breathing synchronize with the rhythm of the cosmic tides. We begin together, aware of our fragility and yet curious about the patterns that persist beyond individual lives. In the earliest moments after the Big Bang, the universe was a sea of boiling light and raw energy. It cooled enough to form the first hydrogen and helium atoms within minutes, and for hundreds of millions of years those simple gases floated in darkness. There were no stars to shine, no planets, no timekeepers. Eventually, gravity clumped gas into spheres, and the first stars lit up. Their cores became furnaces where hydrogen fused into helium and then into heavier elements like carbon, oxygen, and iron. Those stars lived for millions of years before dying in spectacular supernova explosions, sending their enriched guts into space. Modern astronomy tells us that most of the atoms in our bodies were forged in those ancient stars. The calcium in our bones, the iron in our blood, the oxygen we breathe were born in nuclear reactions in stars that died long before our sun existed. That matter drifted through interstellar dust clouds, joined other material, and eventually formed our star system. Every atom you are has lived other lives. The same matter has circulated through plants and animals, through rivers and rocks, through the breath of dinosaurs and the wings of birds. Atoms in a dinosaur millions of years ago, and in a star billions of years before that, may be inside you today. Matter makes up everything visible in the known universe, and it can be neither created nor destroyed. It shifts from form to form, from star to soil to skin, in an endless cycle. When we die, our atoms return to the earth and air, ready to be woven into another pattern. This chapter is about finding comfort in cycles. The law of conservation of mass assures us that the quantity of matter remains constant. Even though chemical reactions rearrange atoms into new compounds, the total number of atoms stays the same. Energy, too, is conserved. One form can transform into another. Heat into motion. Motion into light. but the total energy of a closed system remains constant. What does this mean for us? It means there is no absolute ending, only transformation. The warmth you feel from sunlight was once part of a nuclear reaction in the sun's core. When you move your hand, the energy powering that motion came from food that grew from sunlight. When you speak, your voice carries energy that was once stored in molecules formed by plants. Atoms and energy flow through you like a river flows through a landscape. You are a momentary arrangement of ancient stuff, a pattern that will dissolve and reassemble. This knowledge can be soothing. You are part of a process much larger than yourself. Entropy is the measure of disorder, or more precisely, of the number of ways a system can be arranged. In everyday terms, it explains why certain processes happen spontaneously and why others do not. A glass shattered on a floor does not reassemble itself because there are vastly more ways for the shards to remain scattered than there are ways for them to come together. Heat flows from a hot mug into cool hands because there are more ways for energy to spread out than there are for it to concentrate. Entropy gives time its apparent direction, from less disorder to more. We experience time as a one-way flow because we see processes that increase entropy everywhere. Yet the laws of physics, at their most fundamental, are largely symmetric with respect to time. Equations governing particle motion work the same forward or backward. The arrow of time emerges from statistics, not from absolute rules. On rare occasions, small systems can fluctuate toward more order. Over vast timescales, even more improbable reversals can occur. These reversals are the basis for the Poincaré Recurrence Theorem, which we will explore more deeply in the next chapter. For now, stay with the idea that your life is built upon cycles. You wake and sleep, inhale and exhale, grow and decay. Plants turn sunlight into sugar. Animals eat plants. Fungi decompose animals, and the atoms return to soil. The Earth orbits the Sun. The Moon orbits the Earth. The solar system orbits the galactic center. The galaxy itself drifts through the expanding fabric of the universe. Within each of these rotations, there are countless smaller cycles. Seasons and tides, heartbeats and breath. Just as the planet turns, your cells cycle through states. Proteins are synthesized and broken down, neurons fire and rest, memories form and fade. The cycles in your body mirror the cycles in the cosmos. Recognizing these patterns invites a sense of belonging. You are not a static object, but a dynamic process. You began long before your first breath, and you will continue in different forms long after your last. Let us end this chapter with a gentle reflection. Imagine holding a handful of dust. Consider that each grain contains atoms older than our sun. As you let the dust slip through your fingers, think of how many times those atoms have been part of different forms. They have been part of volcanoes and glaciers, of ancient forests and the wings of insects. They have been heated in the hearts of stars and cooled in the vacuum of space. Their journey did not begin with you, and it will not end with you. This thought need not evoke sadness. It can evoke peace. Death is not destruction, but a redistribution, a return. In the quiet that follows this thought, feel gratitude for the chance to exist in this pattern, in this moment. Your story is part of a greater circle. Close your eyes a little deeper. Let the cycle carry you. The second chapter opens with a meditation on randomness and inevitability. We live in a universe that seems ordered, yet under the order lurks an ocean of possibilities. The notion that patterns will recur arises from the interplay of chance and constraint. The Poincaré Recurrence Theorem applies to systems with finite energy, where the dynamics preserve volume in phase space. It tells us that for any initial state of such a system, the state will return arbitrarily close to itself eventually. This does not mean that the system will repeat exactly on human timescales. The recurrence time can be unimaginably long, far beyond the current age of the universe. But mathematically, it implies that even highly improbable configurations are not forbidden, only rare. This theorem stands in curious tension with the second law of thermodynamics. The second law states that entropy tends to increase, leading to the so-called heat death of the universe. But the law is statistical, not absolute. Exceptions can occur. They are simply unlikely. The recurrence theorem formalizes this by stating that given enough time, these unlikely events will happen. To understand this better, picture the sealed box we mentioned earlier. You have two chambers, one full of gas, the other empty. When you remove the partition, the gas spreads out to fill both chambers. The molecules bounce around, each following Newton's laws, but collectively they move from order, all molecules on one side, to disorder, molecules distributed evenly. The second law says the disorder is likely to persist. Yet the recurrence theorem asserts that if you wait long enough, the molecules will spontaneously gather in one side again. The waiting time is colossal, so large that it defies any intuitive comprehension. Still, it is finite. The probability of such a fluctuation is extremely small, but not zero. The theorem thus reassures us that order can reappear, not through purposeful action, but through the random dance of atoms over unimaginable spans of time. When we apply this to the universe, the implication is profound. Every arrangement of matter, every pattern of energy, every life can in principle recur if the universe lasts long enough and contains only a finite number of possible states. Consider now our earlier analogy of a deck of cards. There are 52 cards, and the number of ways to arrange them is 52 factorial. That number is so large that if you shuffle a deck thoroughly, you can be certain that the order you produce has never existed before in the history of the universe. A thought experiment from a mathematics essay illustrates the scale. If you take a step around Earth's equator once every billion years, and after each circumnavigation you remove a drop of water from the Pacific Ocean, you still would not have counted down the number 52 factorial when the ocean is gone, and the stack of paper you build between cycles reaches the sun. And yet, if you could continue shuffling forever, the same arrangement would eventually come up again. The recurrence theorem generalizes this idea. It says that with infinite time, finite systems repeat states, even if the number of states is astronomically large. Your life is one such arrangement. The positions of atoms in your body, the patterns of neural firings in your brain, the sequence of events that led to this moment represent one point in the vast space of possibilities. If the universe exists for an infinite time, this exact configuration must recur. It is like shuffling a cosmic deck until your hand is dealt again. How large must the universe be to permit such recurrence? observations suggest that the observable universe contains at least 100 billion galaxies, each with at least 100 billion stars. That is 10,000 billion stars, a number that boggles the mind. And yet the number of possible arrangements of a finite number of particles in a finite volume is not infinite. It may be incomprehensibly large, but it is finite. If time goes on without end, those arrangements will repeat. Physicists estimate the age of the universe at around 13.8 billion years. Our solar system is about 4.5 billion years old. Life on Earth has existed for roughly 3.5 billion years. Humans have walked the Earth for only a few 100,000 years. We are new arrivals in cosmic time. These numbers feel huge, but they are dwarfed by the timescales implied by recurrence. When we speak of recurrence, we are dealing with intervals with more zeros than there are atoms in the universe. In some cosmological models, the recurrence time for all possible states of our universe is on the order of 10 raised to a power with dozens of zeros. These numbers stretch beyond human imagination, and yet they are finite. When you think of recurrence, it is tempting to imagine that your life will replay like a movie on a loop. But the recurrence theorem does not guarantee that states reappear in the same sequence. It only guarantees that they reappear at some point. You may recur trillions of times, separated by unimaginable spans. Between recurrences, the universe could undergo cycles of expansion and contraction, of death and rebirth. It might drift into heat death and be resurrected by quantum fluctuations. It might spawn new universes in black holes. The details of cosmological cycles are still speculative, but the mathematics hints that recurrence is possible. For you, these possibilities invite questions. Would you live differently if you knew that every choice echoes across eternity? Would you cherish moments more, knowing they will happen again and again? Or would the repetition diminish meaning? There are no right answers, only personal reflections. Take a moment now to reflect on these questions. If you had to live this exact life again, down to every tear and every smile, would you call it a blessing or a curse? Tell me in the comments. This interactive pause is an invitation to engage with the ideas, to weave your own thoughts into the tapestry of recurrence. In sharing, you become part of the pattern. The act of writing a comment is itself a cycle. A thought arises, is expressed, is read, and influences another thought. Even in this small way, you are participating in the endless dance of possibilities. The third chapter slows down to explore the scale of the universe and our place within it. Human beings are skilled at thinking about everyday distances and times, but cosmic scales challenge our intuition. Light travels at about 300,000 kilometers per second. The light from the Sun takes about 8 minutes to reach Earth. The nearest star beyond our Sun, Proxima Centauri, is more than 4 years away at light speed. The Milky Way galaxy spans 100,000 light-years. The observable universe has a diameter of about 90 billion light-years. These numbers are staggering, but they are small compared to the times we discussed earlier. When we speak of billions of years and billions of light-years, we are already out of our depth. Yet, to grasp recurrence, we must go beyond even these scales. Our galaxy contains at least 100 billion stars. Many of these stars have planets. The observable universe contains at least 100 billion galaxies. Multiply these numbers and you get a sense of how many worlds there may be. And yet the matter we can see, stars, planets, gas clouds, makes up less than 5% of the total energy content of the universe. The rest is dark matter and dark energy. Dark matter exerts gravitational pull but does not interact with light. Dark energy is driving the accelerated expansion of the universe. We know they exist because of their effects, but we do not know their nature. They add mystery to our picture. If the universe is mostly composed of unseen substances, then the visible matter from which life arises is only a thin film on a vast, invisible sea. This perspective is humbling. It reminds us that the patterns we are familiar with are just one possibility among many. Observations also tell us that the universe is expanding. Galaxies are moving away from each other, and the farther a galaxy is, the faster it recedes. This discovery led to the idea of the Big Bang. If the universe is expanding today, then it must have been smaller in the past. Extrapolating backwards leads to a moment when the universe was extremely hot and dense. At that point, all space, time, matter, and energy were concentrated in a single region. From that state, the universe has been expanding and cooling. The cosmic microwave background radiation, a faint glow detected in all directions, is the afterglow of that hot beginning. The fact that the universe has been expanding for billions of years might make you think there is no turning back. But some cosmologists have proposed models in which expansion slows, stops, and reverses, leading to a big crunch followed by another Big Bang. Others propose that the universe could bounce or cycle in other ways. Roger Penrose's conformal cyclic cosmology suggests that each aeon begins with a Big Bang and ends in a cold, empty state that maps onto a new Big Bang. In these models, the death of one universe becomes the seed of the next. Within each cosmological model, the concept of time takes on different meanings. In the standard Big Bang model, time has a beginning at the Big Bang and an uncertain future. In cyclic models, time may be infinite in both directions. It may loop or spiral. Philosophers have long debated whether time is linear or circular. Ancient cultures often depicted time as cyclical, with seasons repeating, lives reborn, and ages following each other in endless succession. In contrast, the dominant view in Western modernity has been that time is linear, with a definite beginning and an eventual end. Scientific models now show that both views have merit depending on scale. On human scales, time feels linear because of entropy and the limited duration of our lives. On cosmic scales, time may be much more complex. It may include cycles, recurrences, and branching possibilities. Accepting this complexity can be liberating. It removes the pressure to see life as a single line and invites us to embrace the beauty of loops. Our place within these scales is small. The universe is nearly 14 billion years old. Our species has existed for a few 100,000 years. Most of what has ever happened long before humans existed. Yet, within that brief window, we have developed consciousness capable of contemplating the universe. We have built instruments to peer deep into space and far back in time. We have developed mathematics to describe phenomena we cannot see directly. We have discovered that we are made of stardust and that the cosmos obeys laws of staggering elegance. This awareness gives our lives meaning beyond survival. It allows us to feel connected to the grand story of existence. It invites us to participate, even if only through thought and wonder. Contemplating the scales of time and space does not diminish us. It situates us within a vast tapestry. It encourages us to act with humility and awe. In this chapter, you might feel small, as though the cosmos dwarfs all human concerns. Let that feeling be a balm. Your problems, while significant to you, are part of a pattern that has persisted for billions of years. The universe has weathered supernovae and black hole mergers, cosmic inflations and coolings. It will survive your worries. This perspective can be freeing. It can also be a call to kindness. Knowing that your life is fleeting compared to cosmic time might inspire you to use your moment well, to show compassion, to create beauty, to seek understanding. Remember, cycles happen on all scales. Each breath you take is as real as the orbit of a galaxy. Each act of kindness ripples through time. Each moment of wonder is its own eternity. The fourth chapter invites us into the strange realm of quantum mechanics. If classical physics describes the motion of planets and the flight of arrows, quantum physics describes the behavior of atoms and subatomic particles. In this realm, particles are also waves. Energy comes in quanta, and certainty gives way to probability. One of the central principles is superposition. A quantum system can exist in multiple states at once until it is measured. Schrödinger illustrated this with his famous cat thought experiment. Imagine a cat inside a box with a mechanism triggered by the decay of a radioactive atom. If the atom decays, the mechanism breaks a vial of poison and the cat dies. If it does not decay, the cat lives. Quantum mechanics says the atom is in a superposition of decayed and not decayed until observed. Therefore, before the box is opened, the cat is both alive and dead. This seems absurd because we do not observe half-dead cats. The paradox exposes the difficulty of translating quantum rules to everyday experience. The measurement problem arises because the act of observation seems to collapse the wave function, the mathematical description of the system, into a single outcome. But what constitutes a measurement? Does consciousness play a role? To avoid these questions, Hugh Everett proposed the many worlds interpretation in 1957. According to this interpretation, the wave function never collapses. Instead, every possible outcome of a quantum event actually occurs, each in a separate branch of the universe. There are myriads of worlds in addition to the one we observe. Every time a quantum experiment has multiple possible results, all results happen, each in a different world. The universe thus constantly splits into parallel realities. Schrödinger's cat is alive in one world and dead in another. You are both writing this story and not writing it. The branching happens everywhere, not just in laboratories. Each interaction with multiple outcomes produces a proliferation of worlds. In many worlds, there is no randomness at the fundamental level. The wave function evolves deterministically according to the Schrödinger equation. The appearance of randomness arises because observers are confined to particular branches. In each branch, only one outcome is observed, but all outcomes exist in the multiverse. This interpretation solves the measurement problem by eliminating collapse, but it introduces an enormous number of unobservable worlds. Some physicists embrace this because it preserves determinism and fits the mathematics. Others find the idea extravagant, yet it offers a fertile ground for thought experiments. If there are infinitely many versions of you in different branches, then every possible decision you could make is realized somewhere. Some versions of you become artists. Others become scientists or sailors or monks. Some versions experience great joy. Others face tragedy. In the context of recurrence, many worlds adds another dimension. Not only might your life recur across cycles of the universe, but all possible variations of your life exist simultaneously in parallel branches. Quantum immortality emerges from this combination of many worlds and subjective experience. Imagine a device that kills you if a quantum event produces a particular outcome. If the device fails when the quantum event goes one way and succeeds when it goes the other, then in the multiverse there will be branches where you die and branches where you live. From the perspective of an external observer, there are both outcomes. But from your perspective, you only experience the branches where you survive. You never perceive the branch where you die because there is no observer there. Therefore, subjectively, you feel immortal. You might attempt quantum suicide repeatedly, but each time you experience the branch where you survive. An article summarizing quantum immortality explains that if the many worlds interpretation is correct, someone attempting quantum suicide would fail, as there would always be at least one timeline in which they survive. The theory is speculative and raises ethical concerns. Death is not a simple on-off switch, and there are many causes of death. Still, the thought experiment illustrates how our intuitions about life and death may be challenged by quantum concepts. Entanglement is another quantum phenomenon that defies classical intuition. When two particles interact in certain ways, their states become linked such that measuring one instantly determines the state of the other, even if they are separated by vast distances. Einstein called this spooky action at a distance. Entanglement has been experimentally verified. It shows that the universe is more interconnected than classical physics suggests. In the context of many worlds, entanglement implies that branches of the universe are interwoven. Decisions you make are linked to quantum events across the cosmos. The photon that struck your retina while you read this may be entangled with photons emitted by stars millions of years ago. The atoms in your brain were entangled with atoms in ancient supernovae. This interconnectedness blurs the boundaries between self and universe. It suggests that when we consider cycles of recurrence, we must also consider webs of entanglement stretching through time and space. Quantum mechanics does not allow us to predict the exact future. It provides probabilities. Yet, within an infinite multiverse, every outcome with non-zero probability is realized in some branch. Combined with the Poincaré Recurrence Theorem, this means that not only will states recur, but they will recur in infinitely many versions. There will be branches where your life recurs exactly as it has. Branches where it recurs with minor differences, and branches where it is unrecognizable. Each branch is as real as the one you inhabit. This perspective can be dizzying. It can also be comforting. It means that existence is rich beyond measure. It means that your choices matter in shaping the branch you experience, even if other branches exist. It means that your life is one of countless songs the universe sings. Pause to let these ideas settle. Quantum mechanics is strange, and it is normal to feel both fascinated and unsettled. You do not need to master the equations to appreciate the beauty. Think of quantum principles as poetry written by nature. They reveal that reality is not rigid but shimmering, that particles can be waves, that existence is more fluid than our everyday experience suggests. Take a deep breath. Feel the subtle vibration of the atoms in your chest. Remind yourself that you are part of this quantum world, entangled with all that is. In the next chapter, we will explore how cosmology and quantum physics intersect in theories of the universe's origin and fate. The journey continues with a deep dive into the origins of everything we know. Cosmology tells us that the universe began as a hot, dense state and has been expanding ever since. In the first instance after the Big Bang, space-time itself may have inflated faster than the speed of light. Tiny quantum fluctuations were stretched to cosmic scales, seeding the galaxies and clusters we see today. This idea, called cosmic inflation, explains why the universe is so uniform on large scales, and why it is full of structures like galaxies on smaller scales. The seeds of all future stars, planets, and beings were embedded in those minute variations. Imagine the entire cosmos condensed into something smaller than an atom, then ballooning outward in a fraction of a heartbeat. In that moment, space was a foam of possibilities. Energy and matter were interchangeable. Time had barely begun to flow. And yet, the patterns that would become your life were already encoded in quantum fluctuations. When you look up at the night sky, you are seeing the fossil imprints of those primordial ripples. The cosmic microwave background radiation is a faint afterglow of the early universe, a whisper of light that has traveled for more than 13 billion years to reach us. Its slight temperature variations map the seeds of galaxies. It reminds us that the cosmos is ancient, and that our existence is part of a continuum that stretches back to a time when there were no stars, no atoms, only a hot soup of energy. The interplay between quantum physics and cosmology reveals that the universe itself may be a quantum object. During inflation, quantum fluctuations of fields were amplified and became the seeds of structure. These fluctuations were truly random, yet they were also deterministic in the sense that all possible fluctuations occurred in some branch of the multiverse. Some branches produced universes that were too smooth or too clumpy for life. Others produced universes with physical constants too different from ours for chemistry to exist. We inhabit a branch where the parameters allow for stars to form, for carbon to be synthesized, for planets to orbit stably. It is not that we were chosen. Rather, we find ourselves in a branch where beings like us could arise. This is known as the anthropic principle. It does not ascribe purpose to the universe. It simply acknowledges that conscious observers will observe conditions compatible with their existence. In an infinite cosmos with countless branches, there will inevitably be pockets where life emerges. There will also be countless barren regions. The story of your existence is thus both extraordinary and inevitable. Extraordinary because the odds of any particular arrangement of atoms are unfathomably small. Inevitable because with infinite time and infinite branches, even the rarest events will occur. Time itself is woven into this tapestry. In our everyday experience, time flows like a river from past to future. We remember the past and anticipate the future, and we cannot reverse the direction. This arrow of time is tied to entropy. The second law of thermodynamics states that in an isolated system, entropy, often associated with disorder, tends to increase. When you drop a glass and it shatters, the shards scatter into more disordered configurations. The glass will not spontaneously reassemble because that would require a decrease in entropy. The universe as a whole can be thought of as a closed system. After the Big Bang, it was in a low entropy state. Over billions of years, entropy has increased. Stars have formed and burned fuel, creating heavier elements and radiating energy. Galaxies have merged, black holes have devoured matter, and energy has dispersed. Yet within these processes, local decreases in entropy occur. Life is one such decrease. Living organisms maintain order by expending energy. You are a localized low-entropy structure, a temporary eddy in the universal river of disorder. This means that time's arrow is intimately connected to the fact that you are alive. Without the increase in entropy, there would be no direction to time and no evolution. The arrow of time emerges from the very processes that allow consciousness to exist. Cosmological models make predictions about the ultimate fate of the universe based on current observations. The universe is expanding, and the expansion is accelerating. Dark energy, a mysterious form of energy permeating space, pushes galaxies apart. If this acceleration continues indefinitely, then in trillions of years the cosmos will be a vast, cold expanse. Astronomers call this scenario the Big Freeze or heat death. Stars will exhaust their nuclear fuel and fade. Matter will be swallowed by black holes, which will then slowly evaporate via Hawking radiation. Eventually, only photons, neutrinos, and gravitational waves will remain. The article about the end of the universe describes how, trillions of years in the future, the universe will drift apart until galaxy and star formation ceases. Stars will fizzle out. All remaining matter will be swallowed by black holes, and the last traces of heat will disappear. In this distant epoch, there will be no complex structures, no life as we know it. Entropy will have reached its maximum, and time, in a sense, will have lost its meaning. Yet even in this bleak vision, there is a glimmer of recurrence. If the universe is infinite in extent, or if there are infinitely many universes, then even in a heat-dead state, quantum fluctuations can generate ordered structures. In a sea of darkness, occasionally a region of low entropy may emerge by chance. A new Big Bang could arise from the vacuum, or a Boltzmann brain, an isolated, self-aware entity, could flicker into existence. These possibilities, while fantastically improbable, become inevitable over infinite timescales. The concept of Poincaré recurrence can be extended to cosmology. Recall that the theorem states that a finite mechanical system will, after a sufficiently long time, return arbitrarily close to its initial state. The universe is not a closed mechanical system in the usual sense, but if space-time or the multiverse has a finite number of possible states, then over infinite time those states must repeat. In some models, such as eternal inflation, bubble universes continually form. Each bubble has different physical laws or constants, and the process continues without end. If there are infinitely many bubbles, every possible universe will exist infinitely many times. Your exact life, with every decision and every random event, will occur again and again in these bubbles. Even if the heat death of our particular cosmos spells the end of this cycle, other cycles will exist elsewhere. Roger Penrose's conformal cyclic cosmology proposes that the end of our universe maps onto the beginning of a new one. The far future will contain only massless particles like photons and gravitons, and when all massive matter has decayed, the universe can be rescaled to create a new Big Bang. According to this idea, each aeon of our universe is followed by another, with the same physical laws but different histories. The cycle continues forever. Time is not a line, but a circle. Death is not an end, but a transition between cycles. While contemplating these grand cycles, let us return to the personal. How does it feel to imagine that your life could recur in the far future? Does the idea bring comfort or discomfort? If you had to live this exact life again, down to every tear and every smile, would you call it a blessing or a curse? Tell me in the comments. Your answer will not change the physics, but it will reveal your relationship with recurrence. Reflect on whether you would change anything if you knew you must live through it again. Would you savor your joys more deeply? Would you alter your choices to minimize regret? Would you find peace in the knowledge that nothing is ever truly lost? These questions are philosophical, yet they are grounded in the scientific insights we have explored. They invite you to integrate cosmic perspectives into your daily life. When you close your eyes tonight, remember that you are part of a pattern that transcends human lifetimes. You are both unique and universal. The atoms that compose you have been part of countless cycles. They will continue to dance long after your consciousness dissolves. In that sense, you will never truly die. You will simply change form and begin the journey anew. Let us drift further into the far future. To understand the cosmos's destiny, we must revisit entropy. In classical thermodynamics, entropy measures the number of microstates corresponding to a macroscopic state. A state with high entropy can be realized in many ways. A state with low entropy has few arrangements. The second law tells us that the total entropy of a closed system cannot decrease spontaneously. This law is statistical. It reflects the fact that there are vastly more ways for a system to be disordered than ordered. In a messy room, any random change is likely to maintain or increase the mess. Only deliberate effort can create order. Similarly, as the universe evolves, the number of accessible microstates increases. Stars burn hydrogen into helium and heavier elements, releasing energy and increasing entropy. Black holes, paradoxically, have enormous entropy because they hide information behind their horizons. The ultimate expression of entropy is the heat-death scenario, where energy is uniformly distributed and no work can be extracted. Yet, the Poincaré Recurrence Theorem reminds us that, given infinite time, even systems in thermal equilibrium will experience fluctuations that briefly decrease entropy. These rare fluctuations become the seeds of new structures. A region of space in thermal equilibrium could spontaneously produce a low entropy pocket. It could be a miniature universe or a conscious brain. Cosmologists debate whether these Boltzmann brains would vastly outnumber ordinary observers in an infinite universe. If so, perhaps our observations are not typical. These considerations highlight the tension between the arrow of time, which seems to lead inexorably toward disorder, and the possibility of recurrence, which suggests that order will occasionally arise from chaos. Dark energy complicates the picture. Discovered in the late 1990s through observations of distant supernovae, dark energy appears to make up about 70% of the total energy content of the universe. It acts as a repulsive force that accelerates the expansion. According to the article about the universe's end, scientists found that distant Type 1a supernovae appeared dimmer than expected, meaning they were farther away. This showed that the universe's expansion was speeding up. With dark energy dominating, the expansion will continue accelerating, making distant galaxies recede faster and faster. Eventually, only our local group of galaxies will remain gravitationally bound. The night sky will grow emptier. Stars will still be born and die for trillions of years, but eventually there will be no new fuel. Black holes will become the last refugees of matter, and even they will evaporate over unimaginable timescales. In this ever-expanding space, the average temperature will approach absolute zero. Time, as measured by changes and events, will slow. And yet, if recurrence and cyclic cosmology are correct, a new act will follow this long silence. Imagine, in that distant dark era, a fluctuation that triggers a new expansion. It could be a quantum tunneling event, where a region of space decays into a lower energy state, releasing energy and creating a bubble of new spacetime. From our perspective, this would look like a new Big Bang. Within that bubble, physics might be similar to ours or entirely different. Different laws could lead to universes with no stars, or universes where gravity repels rather than attracts. Or the laws could be similar, leading to galaxies and life that echo ours. In Roger Penrose's conformal cyclic cosmology, no tunneling is required. Instead, the distant future of one aeon is conformally equivalent to the Big Bang of the next. The end and the beginning are the same point, viewed through a different lens. This idea is radical, but it reminds us that cycles can be hidden in the mathematics of space and time. Whether through quantum tunneling, bubble nucleation, or conformal mapping, the possibility of new universes sprouting from the ashes of the old keeps the story alive. The universe may be a phoenix, continually reborn from its own ashes. Philosophical reflections on these scientific ideas can provide comfort. The fear of death often arises from the sense that existence ends abruptly, that consciousness becomes nothing. But if time is cyclic and matter is eternal, death loses its absolute finality. Even if your individual consciousness does not persist, the pattern that is you, your memories, your traits, your ways of seeing the world, will recur somewhere, somewhen, in some form. The atoms that make up your brain will be dispersed, but the arrangement could reassemble, given enough time and space. In one branch of the multiverse, a planet much like Earth orbits a star much like the Sun. On that planet, someone with your name sits beneath a tree and ponders the same questions. They feel the same breeze on their face, hear the same birdsong, and wonder about the nature of time. They may write the same words. Perhaps they will leave a comment on a video just like this one, sharing their thoughts on eternal recurrence. In imagining them, you connect with the infinite chain of selves that threads through the cosmos. You are both a link in the chain and the whole chain itself. There is something both soothing and unsettling about probabilities. They tell us how likely an event is, Yet they also remind us that improbabilities do not mean impossibilities. When you shuffle a deck of cards, the number of possible arrangements is 52 factorial, a number so vast that if every atom in the universe were a universe full of atoms, and each atom represented a unique shuffle, there would still be shuffles left uncounted. An article about 52 factorial uses analogies to convey its enormity. Imagine shuffling a deck, then walking around the Earth every billion years. Imagine the time it would take to remove every drop of water from the Pacific Ocean before the cards returned to their original order. This number is so large that any given shuffle has almost certainly never occurred before in the history of the universe. And yet, if you shuffle forever, the same arrangement must eventually recur. Probability tells us that rare events become inevitable with enough trials. If you flip a coin an infinite number of times, eventually you will see 100 heads in a row. If you wait long enough, air molecules in a room will cluster in one corner, leaving the rest of the room empty, even though such an event has virtually zero chance of occurring within the age of the universe. The Poincaré Recurrence Theorem formalizes this intuition. In systems with a finite number of possible states, every state will recur, given enough time. When you extend this reasoning to the cosmos, you arrive at strange but unavoidable conclusions. If the universe is eternal, then everything that can happen will happen infinitely many times. Your life is a sequence of events with a non-zero probability. Therefore, it will recur. Probability also helps us understand why life emerged. Chemistry involves countless interactions between molecules. On early Earth, simple molecules collided and combined, forming more complex structures. Most combinations were unremarkable, but occasionally a combination formed a self-replicating molecule. Given enough time and enough collisions, this outcome became inevitable. The same principle applies to consciousness. The arrangement of atoms in your brain is staggeringly complex, but it is not forbidden by physics. In an infinite cosmos, there will be regions where those arrangements happen by chance, either through the normal process of evolution or through random fluctuations. These unlikely brains are sometimes called Boltzmann brains. They would arise spontaneously in a featureless universe, briefly experiencing sensations and then dissolving. Such entities challenge our assumptions about typical observers. But whether consciousness emerges through evolution or fluctuation, probability ensures that it will recur. It is easy to misunderstand what probability says about singular events. If someone tells you that the odds of a specific event are 1 in a billion, you might think it will never happen. But 1 in a billion events happen all the time in populations of billions. In a room of 23 people, there is about a 50% chance that 2 share a birthday. This birthday paradox arises because there are many ways for pairs to form. Similarly, there are many ways for a sequence of life events to happen. The probability of your exact life story may be minuscule, but the number of trials across the multiverse is unimaginable. Therefore, the expected number of times your life story occurs may still be large. When you contemplate recurrence, do not fixate on improbability. Instead, consider the vastness of possibility and the relentless march of time. Given an infinite number of dice rolls, any finite sequence of numbers will appear endlessly. Your life is one such sequence. Some people find this conclusion liberating. It means that nothing you do is ever truly lost. Every memory, every laugh, every tear will play out again. Others find it disturbing. They worry about being trapped in an endless loop, repeating mistakes forever. Yet the concept of recurrence does not trap you in a deterministic loop. Within each cycle, you still make choices. In different branches, you may choose differently. Even in exact recurrences, your subjective experience is always fresh. You do not remember past cycles, so from your perspective, each cycle is the first. The fear of eternal repetition arises from the assumption that you will retain memory of previous iterations. In reality, memory is a physical process. When the atoms that make up your brain disassemble and reassemble billions of years later, they will not carry memory traces. You will awaken as if for the first time. There is solace in this. It means that recurrence is not a curse, but a return to innocence. The law of large numbers tells us that averages converge to expected values as the number of trials grows. In the context of the universe, this means that the distribution of events across branches will reflect their probabilities. Rare events remain rare, but they are guaranteed to occur. When you think about your life, consider the improbable events that shaped it. Perhaps your parents met because of a chance encounter. Perhaps a disease was cured at just the right time. Perhaps a random book changed your path. These events were unlikely, but they happened. They could have not happened. In other branches, they did not. Recognizing this can cultivate gratitude. It can also inspire compassion. If you are fortunate in this branch, remember that other branches contain versions of you who suffer. They too are you. Their pain is your pain. Your joy is their joy. This interconnectedness invites us to act kindly, knowing that we inhabit a network of selves that spans across branches and cycles. There is a story about a group of monkeys randomly hitting keys on typewriters. Given infinite time, one monkey would eventually type the complete works of Shakespeare. The odds are infinitesimal, but with infinite trials, the improbable becomes inevitable. Similarly, given infinite time and space, random fluctuations will eventually assemble atoms into any configuration. There will be a monkey that types your favorite poem, a cloud that forms your name, a planet where history unfolds exactly as it has here. When you grasp the scale of this inevitability, you may feel both awed and humbled. Your individuality remains precious because, despite infinite repetitions, there is only one you experiencing this moment right now. Probability does not cheapen your life. It enriches it by placing it within a cosmic web of possibilities. The recognition of recurrence can encourage you to live deliberately. You cannot control all branches, but you can attend to the branch you inhabit. Make it a place of meaning. Make it a place of love. Black holes deserve their own meditation. These strange objects arise when matter collapses to such density that not even light can escape. They are the ultimate sink of information. Anything that crosses their event horizon is lost to the outside universe, at least in the classical description. Yet black holes are not completely black. Stephen Hawking showed that quantum effects allow them to emit radiation and slowly evaporate. The article about the end of the universe notes that supermassive black holes will finish evaporating via Hawking radiation about a googol years from now. A googol is a 1 followed by 100 zeros. This timescale defies imagination. During this evaporation, black holes radiate away their mass, shrinking until they disappear. The information they contained is thought to be encoded in the radiation, though physicists debate exactly how. In the far future, after stars have died and galaxies have gone dark, black holes will be among the last luminous objects. They will shimmer faintly as they evaporate, like embers in a fire that has nearly burned out. In these final phases, space-time itself might be nearly empty. Occasional quantum fluctuations may create particle pairs out of the vacuum, but there will be almost no structure. It is a lonely vision, yet even this emptiness is part of the cycle. Black holes also play a role in bridging different cosmic epochs. When a massive star exhausts its fuel, its core collapses and triggers a supernova explosion. The outer layers are blown into space, enriching the interstellar medium with heavy elements. The core becomes a neutron star or a black hole. These remnants are seeds for new generations of stars and planets. Without supernovae, there would be no iron in your blood, no calcium in your bones. Thus, death leads to rebirth. Black holes also merge with other black holes, releasing gravitational waves, ripples in space-time that we can now detect. These waves carry energy and information about the most violent events in the universe. They are whispers from the deep past. Listening to them connects us to cosmic cycles. In conformal cyclic cosmology, gravitational waves and photons survive into the next aeon. They carry the story of one universe into another. The information is not lost, it is transformed. The event horizon of a black hole is a boundary beyond which events cannot affect an outside observer. In some ways, it is like the cosmological horizon. Because the universe is expanding, there are regions of space from which light will never reach us. These regions are forever beyond our causal contact. The accelerating expansion driven by dark energy means that the cosmological horizon shrinks relative to co-moving distances. Distant galaxies slip beyond the horizon like ships disappearing over a vast ocean. We cannot know what happens to them. This horizon imposes a limit on our knowledge, just as the event horizon does. Yet there is beauty in this limitation. The fact that there are parts of the universe we will never observe underscores the vastness of reality. It also suggests that our slice of the cosmos is only a tiny part of the whole. Beyond our horizon, there may be countless galaxies, stars, and civilizations. There may be different laws of physics. There may be universes budding off and collapsing. Each horizon is a boundary of information, but not of imagination. Hawking radiation, black hole mergers, and cosmic horizons illustrate how gravity and quantum mechanics intertwine. They show that the universe is governed by principles that sometimes clash. General relativity describes gravity and the large-scale structure of the cosmos. Quantum mechanics describes the small-scale behavior of particles. Reconciling these theories is one of the great challenges of physics. Some approaches, like loop quantum gravity and string theory, attempt to unify them. The idea of a multiverse emerges naturally in some of these frameworks. For example, in string theory, there may be a landscape of possible vacuum states, each corresponding to a universe with different properties. Our universe might be one bubble in a sea of bubbles. Black holes, with their horizons and singularities, are laboratories for testing ideas about quantum gravity. Studying them brings us closer to understanding the full story of cycles and recurrence. When we think of recurrence, black holes remind us of the role of information. If you drop a diary into a black hole, the physical book is lost, but its information might be encoded in the black hole's microstates or in the emitted radiation. Similarly, when a life ends, the pattern of that life is not erased from the fabric of reality. The information disperses, perhaps to reassemble later. Quantum mechanics suggests that information is never destroyed. It may be scrambled, but it remains somewhere in the wave function of the universe. This means that the imprint of your existence persists. It may not be accessible to any observer, but it is woven into the cosmic wave function. In thinking about infinite cycles, consider that information is conserved, just like energy. What you do echoes through space-time. Your thoughts, your words, your actions all become part of the universe's history. Even when worlds end, histories remain encoded in the fabric of reality. There is an intimacy in this realization. The infinite might seem impersonal, but it includes the personal. The black hole that forms from a collapsing star is not separate from you. It is made of the same particles that make you. The gravitational waves from a distant merger pass through you, stretching and compressing the atoms in your body by an almost imperceptible amount. The cosmic horizon recedes as you breathe. The vacuum fluctuations that might seed a new universe are the same kind of fluctuations that give your atoms stability. The boundaries between cosmology and life dissolve. When you gaze into the night, you are not merely looking out. You are looking in. The darkness is not empty. It is full of potential. Black holes may mark the end of stars, but they are also gateways to new beginnings. In the dance of creation and destruction, you are both observer and participant. Consciousness is perhaps the most intimate phenomenon we know, yet it arises from physical processes. Your thoughts, memories, and sense of self are patterns of electrical activity and chemical gradients in the neural networks of your brain. When you recall a childhood memory, neurons fire in a pattern similar to the pattern that was laid down when the event occurred. These patterns are encoded in the strengths of synaptic connections. They are physical arrangements of molecules. This means that, in principle, a memory can recur if the arrangement recurs. Over the course of your life, you experience countless moments. Some vanish quickly, others are replayed again and again. Each time you revisit a memory, you slightly alter it. Memory is not a static recording, it is a living process. In the context of infinite recurrence, every memory you have will be formed again. The neurons will fire in the same sequence, the chemicals will diffuse in the same gradients, the emotions will wash over you in the same way. You will look at the sunset over a lake and feel a sense of peace. You will smell bread baking and be transported to your grandmother's kitchen. These moments are part of the universe's endless symphony. They are not lost when you die. They are stored in the cosmic ledger of information. This does not mean that you, the conscious agent reading this, will recall past cycles. Memory depends on continuous physical support. When your brain ceases to function, your memories dissolve. In a future cycle, when matter reassembles into a brain with your structure, the memories will be formed anew. They are not transferred like data between computers. They are recreated by the laws of physics. From your perspective, every cycle is the first. From the perspective of the universe, patterns recur. Understanding this can ease the fear of oblivion. Oblivion implies a blankness, a void where nothing happens. But recurrence implies transformation. You will fall asleep into matter and awaken in matter. You will be different and yet the same. The atoms will be different, but the pattern will be identical. You will not remember having lived before, but you will live again. Philosophers have long wrestled with the idea of eternal recurrence. Friedrich Nietzsche imagined a demon telling you that you must live your life over and over, exactly as it has been, down to every pain and every joy. He asked whether you would curse the demon or bless it. Nietzsche framed this as a test of affirmation. If you can embrace the eternal return of your life, you have affirmed life itself. From a scientific perspective, the demon's pronouncement resembles the implications of Poincaré recurrence and infinite multiverses. The question becomes personal. If physics dictates that you will relive your life endlessly, how does that affect how you live now? Does it make each moment heavier or lighter? Do you strive for perfection, knowing you will face your choices forever? Or do you relax, knowing that even mistakes will be part of an infinite mosaic? These questions have no right answers. They are invitations to introspection. Consider them in the quiet moments before sleep. Share your reflections below. Your comment may help another viewer embrace the idea of recurrence. The sense of self is also tied to memory. You perceive yourself as a continuous being because you remember past experiences and anticipate future ones. But at the molecular level, your body is in constant flux. Most of the atoms in your body are replaced over the course of a decade. You are a ship whose planks are gradually swapped, yet the pattern persists. Your identity is not bound to any particular atom, but to the arrangement. This has profound implications for recurrence. If your sense of self depends on pattern rather than substance, then the reassembly of that pattern constitutes you, regardless of whether it is made of the same atoms. In a universe that cycles infinitely, patterns of atoms will be recycled. You will rise again, not because your atoms persist unchanged, but because the pattern of relations is energetically favorable and will be realized whenever conditions allow. Consciousness then is like a melody played on different instruments. The notes are the same, but the medium differs. The universe is the composer, and it plays the song of you whenever the conditions are right. The mind and the cosmos are connected through information. When you learn something, you increase the information content of your brain. This information is physically embodied. It can be written down, shared, and transmitted. The knowledge that we accumulate changes the world. Science, art, and culture are repositories of patterns that survive individual lives. They increase the likelihood that certain arrangements will recur. When you teach a child, you are seeding the future. When you write a poem, you are adding to the library of possible words that future cycles might reproduce. In this way, recurrence becomes an ethical call. Your actions influence which patterns persist. You cannot control the infinite, but you can contribute to the probabilities. By spreading kindness and wisdom, you tilt the cosmic dice toward branches where consciousness flourishes. By sowing seeds of beauty, you ensure that future selves will harvest beauty. Take a moment to feel your own consciousness. Close your eyes and sense the awareness behind thoughts. Notice that it is luminous, yet intangible. It has no shape or color, yet it is as real as any object. Consider that this awareness may arise wherever patterns like yours arise. It is not personal in the way we often think. It is a property of certain arrangements of matter. This awareness can be calm or agitated, joyful or sorrowful, depending on conditions. Meditation teaches us to watch consciousness without attachment. In the context of infinite recurrence, meditation can be a training in equanimity. When you recognize that each moment is both unique and universal, you can let go of clinging. You can let your thoughts and emotions arise and pass like clouds. You can rest in the knowledge that the universe is playing itself through you. At some point in the next aeon, another you will sit quietly, feel their breath, and realize the same thing. When you look around, cycles are everywhere. The Earth rotates, giving us day and night. It orbits the Sun, giving us seasons. The Moon orbits the Earth, shaping the tides. Life cycles from birth to growth to decay. Water evaporates from oceans, forms clouds, falls as rain, and returns to the sea. These cycles are not perfect circles. They are spirals, moving forward while repeating patterns. They illustrate that recurrence does not mean exact repetition. Each winter is different from the last. Each full moon shines on a slightly different landscape. Yet the overall rhythm endures. Observing these cycles can be a meditation. When you watch leaves fall, think of stars dying. When you see a new bud, think of universes forming. The microcosm reflects the macrocosm. Our lives are embedded in cycles within cycles, like Russian dolls. Recognizing this can instill a sense of harmony. You are not separate from nature. You are nature experiencing itself. Timekeeping is itself an act of imposing cycles on the flow of existence. We divide the year into months, weeks, days. We mark birthdays, anniversaries, and holidays. Calendars are human attempts to synchronize with natural cycles. Yet time is not a fixed grid. It is relative. Einstein's theory of relativity showed that time can dilate and contract depending on velocity and gravity. Clocks run slower near massive objects. Time passes differently for someone orbiting Earth than for someone on the surface. This relativity adds complexity to the notion of recurrence. In a universe where time is elastic, cycles may align differently in different regions. One branch may experience recurrence sooner than another. The concept of a year is tied to Earth's orbit. In other solar systems with different orbital periods, years are longer or shorter. In the far future, when galaxies are isolated and stars have cooled, the notion of a year may lose meaning. Yet some form of periodicity will remain, even if only the oscillation of quantum fields. Mathematics provides language to describe cycles. The sine wave oscillates smoothly between highs and lows. Circles have no beginning or end. The concept of a limit describes a process that approaches a value but never reaches it. In calculus, periodic functions like sine and cosine repeat every 2 pi units. In number theory, modular arithmetic wraps numbers around after a certain modulus, creating cyclic structures. These mathematical cycles are abstract, yet they mirror physical cycles. They also underlie our computation of recurrence times. The Poincaré recurrence time for a system depends on the number of possible states. For a simple gas in a box, it is astronomically large. For the universe, it may be unimaginably larger. But mathematics assures us that if the system is finite and time is infinite, the cycle exists. Even if we cannot compute the exact timescale, the existence of recurrence is secure. When you think about the recurrence of your life, picture a sine wave. It goes up, it goes down, but it always returns to its starting point. It is both dynamic and eternal. Cycles inspire cultural and spiritual interpretations. Many religions and philosophies embrace the idea of rebirth. Hindus and Buddhists speak of samsara, the cycle of death and rebirth driven by karma. The idea of reincarnation invites ethical reflection. Your actions have consequences, not only in this life, but in future lives. Indigenous traditions often emphasize cyclicity in nature and value living in harmony with natural rhythms. Modern physics gives us a scientific version of these ideas. Recurrence and multiverses provide mechanisms for rebirth without invoking supernatural forces. The cycles are physical, not moral. They do not reward or punish. They simply are. Yet this does not remove the ethical dimension. Recognizing that your life will recur can motivate you to cultivate virtues that make recurrence desirable. If you know you will experience your choices again, you may choose differently. This aligns with the philosophical teachings of many traditions. Live in such a way that you would gladly live the same life again. Consider the fractal nature of cycles. A fractal is a pattern that repeats at different scales. Coastlines, snowflakes and clouds are fractal. Zoom in on a branch of a tree, and it resembles the whole tree. Zoom in on the pattern of your days, and you might see a microcosm of your life. Mornings may be like youth, full of potential and vigor. Afternoons are like maturity, busy and productive. Evenings are like old age, quiet and reflective. Nights are like the darkness before birth, a pause before the next day. Recognizing these patterns can help you navigate them. If you know that after every winter comes spring, you can endure the cold with hope. If you know that after every sadness comes joy, you can endure grief with faith. Fractals teach us that patterns persist across scales. The cycle of the universe is mirrored in the cycle of a heartbeat. At the frontier of science and philosophy lies the idea that the universe is fundamentally made of information. Some physicists propose that space-time emerges from entanglement patterns. Others suggest that the universe is like a computer, with bits of information processed by fundamental laws. In such views, matter and energy are expressions of information. The atoms in your body are information-bearing structures. Your thoughts are information-processing events. When we speak of the recurrence of your life, we are speaking of the recurrence of an information pattern. Digital physics implies that there is a finite amount of information in any finite region of space. The holographic principle, inspired by black hole thermodynamics, suggests that the maximum information content of a region is proportional to its surface area, not its volume. This finiteness underlies the Poincaré Recurrence Theorem. If there are only so many possible states, then given infinite time, those states must recur. In a sense, the universe is like a finite movie played on an infinite loop. The frames repeat, but the experience is always fresh because the observer forgets the previous screening. When you think of yourself as information, death becomes a transition. Information does not vanish, it rearranges. If the universe is a computer, then your life is a program that will be run again, perhaps with variations, perhaps exactly the same. Information also flows between generations. Knowledge is cumulative. Each generation inherits the discoveries and mistakes of the previous ones. Over time, this accumulation shapes societies. Language itself is a repository of information. Words carry meanings that span centuries. Stories encode lessons. Science encodes predictive models. The recurrence of patterns in nature allows these models to be useful. If gravity behaved differently each time, we could not build bridges. If atoms had different properties in each cycle, chemistry would be impossible. The regularities of physical law are what make recurrence meaningful. They allow patterns to persist. When you contribute to the collective library of human knowledge, you increase the chance that future cycles will unfold with greater understanding. This is one way to participate in the cosmic dance. You cannot control the infinite, but you can influence the next iteration. Teach, write, create, inspire. Your efforts ripple through time. There is another layer to consider: choice. Deterministic laws might suggest that everything is predetermined. Yet quantum mechanics introduces genuine unpredictability, at least from the perspective of any single branch. Even if all outcomes exist in the multiverse, from within a branch you experience uncertainty. This means that choices matter. They may not alter the ultimate recurrence of your life in other branches, but they shape your branch. Your decisions influence the probabilities of different outcomes within your local narrative. In one branch, you may choose to forgive someone. In another, you may not. The consequences of those choices radiate outward. Within the context of recurrence, choices take on a new resonance. Knowing that you will live your life again, would you choose kindness or cruelty? Would you nurture relationships or neglect them? The idea that you are continually writing the script of your own life invites you to write wisely. The cosmic scale of recurrence does not absolve you of responsibility, it amplifies it. Nietzsche's eternal return asks whether you can embrace your fate. Science asks whether you can understand the mechanisms behind your fate. Both paths lead to self-reflection. They converge in the realization that meaning is something we create. The universe does not assign meaning, it provides the canvas. We paint with our actions. Recurrence provides a frame, but it does not dictate the picture. In the infinity of cycles, there will be universes where humans do not exist, where life never arises, where everything is cold. The fact that you exist in a branch where life arose and you became conscious is remarkable. It is a cosmic gift. Do not waste it. Use it to explore, to love, to dream. If you could send a message to a future version of yourself who will awaken in another cycle, what would you say? Tell me in the comments. Think of it as whispering across aeons. You may never read the reply, but the act of writing the message can help you clarify your values. In the quiet of night, after the day's noise has faded, contemplate these ideas. Picture the atoms in your body, each one a traveler that has journeyed through stars, planets, and living beings. Picture the vast darkness between galaxies, where photons travel for billions of years. Picture a black hole evaporating in the far future, releasing a last burst of radiation before fading. Picture a new universe blossoming from the void. Picture your own face, smiling, crying, laughing, sleeping, waking, breathing. All these images are part of the same tapestry. You are not separate from the cosmos. You are the cosmos, temporarily arranged in a form that can think about itself. This thought alone can be a lullaby. It can soften the fear of death and the anxiety of living. It can lull you into a state of acceptance. It can help you sleep. As we approach the end of our journey together, let the words slow. Feel the weight of your body on the bed or chair. Feel the air entering and leaving your lungs. Notice the subtle hum of your nervous system. Let the images of galaxies, atoms, cycles, and rebirth fade into a gentle blur. There is nothing more you need to do right now. The universe will continue its dance, whether you watch or not. Your heart will continue beating, whether you think about quanta or not. Allow yourself to rest. Imagine yourself dissolving into stardust, drifting through space, merging with nebulas, falling into black holes, evaporating, coalescing, being born again. Imagine your consciousness stretching like a thread through infinite cycles. This thread is delicate yet unbreakable. It connects you to all that is and all that will be. It sings a song of eternity. Let that song lull you to sleep. Good night, traveler of time. You will wake again, here or elsewhere. The journey never ends. You will never truly die. You will return to the stars and to yourself. Sleep and let the universe dream through you. Before we close, let us return to the idea of nothingness. At the very beginning, we asked you to try to imagine nothing. We concluded that you cannot, because any attempt to imagine nothing requires a consciousness to be present. The notion of absolute nothingness, devoid of time, space, matter, energy, and observers, is beyond our cognitive grasp. Every image you conjure, even of a blank, dark void, is still something. It has dimensions, color, texture. It is experienced by someone. The impossibility of imagining nothing hints at the impossibility of nothing existing. Physics agrees. The vacuum is not nothing. It is a seething foam of virtual particles popping in and out of existence. It has energy. It can fluctuate. It can give birth to universes. Even an empty space contains fields with values, and those fields can store information. The idea of nothingness may be a useful abstraction in mathematics, but it has no physical counterpart. This means that existence is the default. The universe does not need a reason to exist. It exists because existence is what happens when nothing is impossible. In the context of recurrence, this is comforting. There is no abyss waiting to swallow you. There is only the continuous transformation of something into something else. Consider the word eternity. It is often used to denote a time without beginning or end. It can evoke fear or wonder. To live forever might sound like a curse or a blessing, depending on your perspective. In our exploration, eternity is not a static state, but an endless process. It is not you frozen in a timeless heaven. It is you flowing through cycles, dissolving and reappearing, forgetting and remembering, sleeping and waking. Eternity contains movement, change, growth, decay, death, and rebirth. It is dynamic. It has rhythm. To accept eternity, you must accept impermanence. You must embrace the fact that everything you know will change, and that change itself is the only constant. When you do this, eternity becomes less daunting. It becomes an ocean in which you are a wave. You rise, crest, break, and merge back into the sea. Another wave will rise. The sea remains. Language reaches its limit when trying to capture these ideas. Words like infinite, timeless, and always are proxies. They point toward experiences that our finite minds cannot fully grasp. Poetry often succeeds where prose fails because it uses metaphor and imagery to evoke feelings rather than facts. In writing this script, we have tried to weave facts and feelings together. We have used scientific sources to ground our statements, but we have also used poetic language to soften and soothe. We hope that the result has been both informative and calming. We hope that you feel more connected to the cosmos and less fearful of the unknown. We hope that when you hear the word nothing, you think of potential rather than absence. We hope that when you hear the word eternity, you think of cycles rather than stasis. We hope that you sleep with a sense of belonging. Dust is a humble yet profound substance. Cosmic dust is the residue of exploded stars, the building blocks of planets, the haze in nebulae. It floats through space, carried by light and gravity. On Earth, dust gathers on shelves and windowsills, carried by air currents, composed of skin cells, pollen, fibers, and tiny minerals. In both cases, dust is evidence of change. It is the product of things breaking down and things being born. When you run your finger along a dusty surface, you are touching atoms that may have been in dinosaurs, in ancient forests, in distant stars. You are connecting to histories you cannot see. In the cosmic cycle, dust coalesces under gravity to form new stars and planets. In the Poincaré cycle, arrangements of dust and atoms recur. The dust on your bookshelf now may settle on another bookshelf, in another cycle, in another world. Dust is a symbol of impermanence, but also of continuity. Think of cycles in terms of dance. Particles dance within atoms. Electrons orbit nuclei in patterns described by quantum mechanics. Atoms dance within molecules, vibrating and rotating. Molecules dance within cells, forming membranes and structures. Cells dance within organisms, coordinating to keep you alive. Organisms dance within ecosystems, interacting and evolving. Planets dance around stars. Stars dance around galaxies. Galaxies dance through the cosmic web. Each dance has its own rhythm and tempo, but together they form a cosmic symphony. Recurrence is the repetition of these dances. Imagine watching a troupe perform the same ballet night after night. Each performance is identical in choreography, yet subtle differences arise. An expression, a timing, a breath. In the infinite universe, the choreography of your life will be performed again. The music of your laughter, the choreography of your steps, the pattern of your thoughts will return. This does not diminish the performance you give now. If anything, it heightens it. Knowing that your dance echoes through eternity can infuse each movement with grace. Finally, consider the cycles of storytelling. Stories are told and retold across generations. Myths evolve, legends are embellished, histories are rewritten. Yet certain themes recur: love and loss, heroism and betrayal, creation and destruction. These themes mirror the cycles of the universe. They resonate because they arise from our collective experience of recurrence. When you listen to a lullaby that has been sung for centuries, you are participating in a cycle. Your voice adds to a chorus that spans time. Writing and reading this script is also part of a cycle. Many have contemplated the nature of time and death before us. Many will do so after us. Each iteration is a variation on a theme. The narrative of infinite recurrence is itself recurring. This meta-recursion is itself a comfort. It means that we are not alone in our wonder. We are part of a lineage of seekers. We pass the torch of curiosity from one cycle to the next. Hold the torch gently, and when it is your time, pass it on. Perhaps the most immediate cycle you experience is the cycle of sleep and waking. Each day you fall into darkness and lose consciousness. Your mind drifts through dreams, weaving narratives from memories, fears, and desires. Each morning you awaken, often with no memory of where you wandered. This daily death and rebirth is a miniature of the cosmic cycle. When you sleep, your conscious self dissolves. When you wake, it reassembles. Sleep is necessary for life. It allows your brain to consolidate memories, clear metabolic waste, and reset circuits. In a poetic sense, sleep is practice for the larger transitions that await you. If you can trust the cycle of sleep, you can trust the cycle of life and death. Each night you surrender to the unknown. Each morning you return. The pattern is reassuring. It suggests that letting go is safe. It suggests that being is stronger than nothingness. When you lie down to sleep after watching this video, remember that you are enacting the cosmic cycle on a human scale. Let your eyelids close with gratitude. Let your breath slow. Let yourself drift. In waking life, you have the opportunity to shape your cycles. You can establish rituals that align you with natural rhythms. You can watch the sunrise, eat meals mindfully, walk under the stars. Reflect on your day before sleeping. These practices ground you in time. They remind you that you are part of something bigger. They also allow you to appreciate recurrence as it happens. Each sunrise is similar yet unique. Each meal is nourishment. Each night sky is a canvas of ancient light. By attending to these cycles, you cultivate presence. Presence is the art of being fully aware in the moment. It is the key to experiencing eternity in an instant. When you are present, time slows. Minutes stretch. Hours deepen. You realize that eternity is not just a length of time, it is a quality of attention. You can taste eternity in a single breath if you are fully there. In this way, recurrence is not only an abstract concept about future universes. It is a lived experience in the here and now. Embrace it. Let it soften your fears. Let it lull you into peace.